In the first example, we're going to see, or two independent sample distributions today. First, we're going to see an example of two means when the population standard deviations, sigma 1 and sigma 2, are known. So a consumer group is testing camp stoves, tests the heating capacity of a stove. It measures the time required to bring 2 quarts of water from 50 degrees to boiling. 2 competing models are under consideration. 10 stoves from the first model and stoves from the second model are tested. The following results are here. Assume that bring water to boil, the time is normally distributed. Is there any difference either way between the two models? Use a 5% level of significance. So the first thing you have to do is establish what's your level of significance. It's 5%, so it's 0.05. Your HO is that your null hypothesis, you're assuming that the two means are equal. So we're going to say mu1's equal to mu2. We're assuming that the mean times are equal. Okay? What are we trying to prove? We're trying to prove there's a difference in any way. So we're trying to prove the alternate's going to be mu1's not equal to mu2. So I'm trying to prove that they're different. So I assume that they're the same, and I'm trying to prove they're different. The next thing we're going to have to establish is what distribution are we going to use. Okay, in this case today, for this example, we're going to use the standard normal distribution. Okay, why the standard normal? Because we assume, and we actually were given this, that the population distributions are approximately normal with known standard deviations. Okay, and so what that means is we know, you could say sigma 1 and sigma 2. So whenever sigma 1 and sigma 2 are known, we use the standard normal model, which is the Z model, okay? Now, you cannot do this in salts. You cannot do this one in salt. This is the only one you can't do in salt. You'll have to use your calculator. I'm going to do calculator first, and then I'll do by hand later. So how do you do this in the calculator? We go to stats, test, and it's a 2-sample Z-test. A 2-sample Z-test. 2, because we have because it's 2 samples, 1 and 2, and then Z, because we're using the standard normal model because these two are known. So 2-sample Z-test. This is the only one you're going to have your calculator for this today. Data or stats, well, they give us the statistics right here. So I'm going to select stats. Okay, and then sigma 1 is 2.5, so I'm just plugging in here. Sigma 2 is 3.0. X bar 1 is 11.4. X bar 2 is 9.9, so 11.4, 9.9. This is not that difficult, just knowing. Oh, sorry, N1. I didn't pay attention. N1 is 10. That's 9.9. And then N2 is 12. This is greater than, sorry, this is out of order, greater than mu2. Or no, or not equal to. I apologize, not equal to. Not equal to, right there. I apologize about that. Calculate or draw. I like doing the draw feature, but my calculator's been, it's giving me an error on that. Let me go to stat calc test. Let me turn these stat plots off for stat test 2-sample Z test. Let's try this again. See if it will. Oh, Z test. Sorry. Stat test 2-sample Z test. Okay. Let me try if the draw will work this time. There we go. Ignore that. Whatever that is. Okay. Ignore that too. So there's the drawing feature. The drawing feature shows you that it's a two-tailed test. So you got shading on the left and the right. That's why there's shading on both ends, because it's two-tailed, because it's different. Z equals 1.28. The p-value is 0.2008. Okay. So there's our Z and p-value. And now we're going to compare our p-value to alpha. How does p-value compare to alpha? P-value is what compared to alpha? Alpha is 0.05. Is it greater than alpha or less than alpha? Greater than, right? When it's greater than, what do we do? Okay, which greater than, we fail to reject ho. Now, so it's greater than, we fail to reject ho, and it's less than, we reject ho. Now, is that significant or not when you fail to reject ho? Not statistically significant. So this means that it's like not guilty. We weren't able to prove. So basically, we'll kind of talk about this in a moment. We weren't able to prove that there's a difference between the two stoves. So failed to reject host, not statistically significant. So in your last statement, you'll say we failed to reject ho. And so we would say we have, when you fail to reject ho, we have insufficient evidence. Insufficient evidence to suggest or to say that there's a difference between the performances of the two models. To say that there is a difference in the performance of the two models. That's really all you have to know. I'm going to do by hand here in just a moment. All right. So that's how you'll need to know for your, and you have to know, you have to use a calculator. You could also do this by hand. I'm going to show you real quickly how to do this by hand, which I'm using the calculator on a lot of this anyways. So the formula is, you got to first find the test statistic. The test statistic is Z, and the formula is you do the statistic, which the statistic in this case is the difference between the sample means minus the hypothesized mean. What does the hypothesized mean? That's mu1 minus mu2. It's the hypothesized difference. We'll talk about that in a moment. Divided by the standard deviation for two samples, it's the square root of sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. So that's how I calculate the test statistic. So that's equal to x bar 1 minus x bar 2. So it's 11.4 minus 9.9 minus, now the difference between the two, the hypothesized mean, the difference between the true means. Now let's talk about this. I'm assuming that they're equal. So if I'm assuming they're equal, what's their difference? There is no difference. So this is going to be 0. So when you assume they're equal, this value right here will be 0 divided by the square root of 2.5 squared divided by 10 plus 3.0 squared divided by 12. This will give me the Z value. Okay. So 11.4 minus 9.9 divided by the square root of 2.5 squared divided by 10 plus 3.0 squared divided by 12. Okay, we do that. Whoops, close that parenthesis. And you get 1.279, so 1.28. There's your Z. So now I've got to calculate the p-value. So how do I calculate the p-value? I'm going to draw a standard normal curve. For a standard normal curve, you have Z as the 0 is the middle. Okay, now the 1.28, I'll plot that. That's up here somewhere. Now the question is, I got to look at what tail this is. And this is called a two-tail test because there's two tails. So I've got to plot the negative of this as well. And so both of these tails are going to be shaded. So I have to find the area of this shaded region. Okay. So what I could do is I could find one of these shaded regions and double it because it's symmetric. So I'm going to find this region right here. And I could use normal CDF to do that. Second vars. Where my lower bound's 1.28. My upper bound's a big number like 100. 0's the mean, 1's the standard deviation. And I could find that. And then I'm going to double that. So second vars, normal CDF. 1.28 to some big number. Mean is 0. Standard deviation is 1. 0.10027. And so what I'm going to do is I'm going to double that. I'm going to times that by 2. That's going to give me my p-value, which is pretty close to what the original. That one's a little bit more accurate. So 0.1, I'm going to put 0.1003. 4 spots times 2 to be 0.02006. And so that's my p-value. It's a little different from that, but you're still going to have the same result.